My name is Hahna.
And my name is Veronica, also known as Ron.
And we are going to demonstrate physics and Newton's 3 laws
of motion.
Our first law that we're going to show you states,
It states, an object at rest remains at rest, and an object in motion continues in motion with constant velocity. That is, constant speed in a straight line unless it experiences a net external force, such as inertia.
So right now we are going to demonstrate inertia.
Yes, watch us on our experience. Hello, Hannah is driving while I will give you guys the tutorial of what is going on. As you can see, we will be going on this road. Oh my, hold on, buckle up. There's a car. I forgot to find my sheep on, but we will show you what happens. Left turn! Ah! Oh my god, the left turn was intense. Now here comes another. As you could see, I could not control myself of what was happening because of inertia. My body wanted to go in a constant velocity in the same direction, but because of inertia, I was uncontrolled and forced me to go the opposite direction. Just to let you guys know, if you didn't catch a hang of that. And just to let you know, we did pass a truck, so we were forced even more to go on the other side of the road more because of Morgan's dad. The stupid Escalade! Come on! No! Okay.
Now we will show you a hard stop.
Now we're going to show you a hard stop and what happens. Ah, that's the brakes! Oh my gosh! Ah, my arm! I need a band-aid. Okay. Ah! Okay! I need knee pads. Helmet. Okay. That was rough. I hope you guys put on your seatbelts, you know. I hope you guys had them on. Oh, we're pulling over. Oh my god, emergency! Okie dokie. That was our demonstration of the S-curve and inertia and of Newton's first law. May I remind you what Newton's first law is? An object at rest remains at rest, and an object in motion continues in motion with constant velocity. That is constant speed in a straight line unless experience a net external force, such as inertia. Stupid off guard.
Right now we are going to demonstrate Newton's second law of motion. Newton's second law of motion states that the acceleration of an object is directly proportional to the net external force acting on the object and inversely proportional to the mass of the object. In other words, F equals ma. So right now we are at a constant velocity of 0, and we are going to apply more force and accelerate because we have the same mass.
See, as we are now at 0, I am neither pressing my foot on the gas or on the brake, therefore at a constant velocity.
So now we're going to speed up as shown on the speedometer.
Wow, this is nice.
We got lots of horsepower.
Oh yeah!
So now we're speeding up and we're almost to 20.
Oh yeah, guys, stay on the road,
And now we are going to
stay at a constant velocity.
stay at a constant velocity
by setting cruise control.
By setting cruise control to 20.
Oh, you did set cruise control.
Well, you just hold it because cruise control's broken.
Okay.
So now we're going at a constant rate of velocity because we're applying the same amount of force to the same mass, which is giving us the same acceleration. Now we are going to slow down.
Slowing.
Now we are applying less force to the same amount of mass, so we get less acceleration.
And see, as our speedometer goes down to 0.
And we're almost back to 0.
About 27 seconds. Oh yeah, look at that baby. Oh my god, hands on the wheel.
And now we are at 0.
And as you can see now, our acceleration has decreased. to where we are barely moving on the road, but still at a constant velocity right now because my foot is neither on the brake or the accelerator, aka gas pedal.
We need a pit stop because we need some tape. So we're going to Maggie's house to get some tape.
Alright, we were going to use bubble gum, but well, my parents won't let me chew gum because it's too sugary. It's hyperactive. Oh my god, dogs! They're so dangerous.
Oh, jeez.
Oh god,
Oh.
big squeeze. Oh my, big old dogs.
So we're going to get some tape.
Move, stupid dogs.
Jeez, this is going to take forever.
Oh my god. Like, I'll probably grow my beard if I just
That's fine, Ron. Yeah, you're on video because
Have we
we're gonna
started?
pit stop for some tape.
Oh. We are gonna borrow some tape.
Okay, thanks.
I'm allergic to dogs. Do you have the faces? Oh my god! Hahna! Dogs are like hitting my back and jumping on me. They're licking my hand. I need some hand sanitizer like ASAP. Okay. As you can see, these faces slash people that we are going to use will be for our next demonstration. Look at how perfect she does that. If you'd like to, you can hand me some pieces of tape.
We need them all on this side.
Oh,
Okay, so we showed you what it was like to change the acceleration with the equal mass and just add more force. So now we're going to add more mass and show you how it's different and how you get less acceleration with more mass because you have to divide the force. So, here we go.
Oh, and as you can see, we have more guests joining us. Yes.
This is really hard. With more people in the car weighs more, so it's harder to push. Okay. It's okay. So now we're going to show you what it's like to have less people in the car. And it's going to be easier to push because there's less mass, so there's less to divide by. Go. Yeah! It's going! It's going! Woo!
Yeah.
And that's the conclusion of Newton's second law of gravity.
Second.
Or second law of motion. Second law of motion.
Yeah.
Okay. Now we are going to demonstrate the final one of Newton's laws of motion.
Third.
The third. The third law of motion states, if two bodies interact, the magnitude of the force exerted on object 1 by object 2 is equal to the magnitude of the force simultaneously exerted on object 2 by object 1. And these two forces are in the opposite direction.
As a demonstration, I will show a reaction and reaction pair. If you could please move forward and examine me. Thank you. What I will do, I will take my right hand and I will push against the car. Now, the action is my hand pushing against the car. The force of me is traveling towards the car. The reaction is the car pushing against my hand towards the opposite direction. Yes, it is in still motion. It has no motion, but its force is still pushing against mine. Therefore, a action and reaction pair.